Good morning, everyone. It's really nice to connect with you over video, and really thank you to Ron Hawkins for the opportunity, and to SDSC team for the opportunity to present here. I want to start out with a little bit of history, I guess. Going back almost a year to date, I was just looking back at my notes and calendar. It was July 17th to be precise, 2019. And I had traveled down to San Diego to meet with Ron as well as the SDSC team to give them their first introduction into the EPYC product as well as the AMD server CPU roadmap, etc. And that got them really excited and got the ball rolling. And as Ron mentioned, actually 4 months later at Supercompute 2019, they announced the availability of or the introduction or the adoption of AMD EPYC-based servers into the SDSC data center. So we're really excited about this partnership with SDSC and look forward to a long, successful collaboration here. So with that, I'm going to dive into the presentation. Today, as Ron introduced me, I'll take a minute as well to talk about myself. I'm a Senior Director in the Data Center Ecosystem Alliance and Solution team. In a nutshell, I work with industry partners on both hardware and the software side and enable the ecosystem readiness, enable solutions, and work with different partners across different verticals as well. So that's kind of my role, and really excited to be here to give you an update today on the EPYC product. If you don't know much about it, I'll go into some level of detail, and then also the applicability, the adoption, as well as touch upon a bit on our roadmap and some performance, etc., just to get you fully up to speed on this exciting new product that we have. So with that, I'll jump into the presentation. If you do have questions, I'm happy to take them during the meeting, and I'll definitely have sufficient time at the end to answer questions as well. If you are comfortable posting it on the chat window, someone in the team will look to address them if possible, and if not, we will address it at the end or after the meeting. So with that, let me just start and give you kind of take you back a few years and give you a little bit of background on our journey. Really, it's a journey. I mean, AMD, for many of you who know AMD, we're not a stranger to the data center. In fact, we had several firsts in the industry, including the x86 64-bit architecture. AMD pioneered that. In fact, it's AMD 64 that's widely used in the industry. A little bit of industry secret now that you're part of it as well. That's one of the innovations, first to virtualization, and going back 15 years, we had a very, very strong presence in the data center market, and of course, due to a variety of reasons, we kind of lost momentum and kind of lost our way. So what we did several years back, going back almost 8 years, we kind of really went back to our understanding our core strengths and really working on a product that can truly be a differentiated product in terms of performance, in terms of several other features. And our first product that we introduced is the EPYC. Now the code name is now EPYC EPYC. And the first server product that we reintroduced in the market happened in 2017. At the same time, we also announced that we've made a long-term data center commitment. So what that means is that we have a very strong, robust roadmap, which I'll touch upon as well, that we've invested very heavily, again, going back several years now, and we continue to execute to that. I think one of the key differences with the new AMD right now is you can see that not only we are committed to a long-term roadmap, but also we are consistently executing to our roadmap. And you've seen other competitors, both x86 and ARM, struggle to really do that. So we've been lucky and blessed. Obviously, it comes through rigorous execution on our side, but we've now delivered our second generation as well. So I'll talk about that as well. So we made the roadmap commitment as well as reintroduced our a new product family codenamed EPYC in 2017. The first product was called Naples, the Italian city Naples. You'll see that also consistent in our product naming convention going forward. Those are Italian cities for now. They could change later, but and really
Dilip?
what we yes, hello.
Hey, are you advancing your slides?
No, I'm still on the first slide. Yeah.
Okay, perfect. Thanks. Sorry.
No problem. Continuing on here, just wanted to take a minute and just give you a little bit more background as well. So we introduced, as I said, in 2017, we brought innovation back into the market. So I'll talk about some of the key innovations that we're bringing. Clearly, performance leadership is one of them. The other area is obviously performance per dollar, performance per watt, as well as a number of other features that we're bringing, including security areas that we really pioneered. So those are the kind of the hallmarks of our new product family, and you will see that in the subsequent slides. So now I talked about the first generation product. Now I want to spend a little bit of time on the second generation product, which was launched into the market last year. You might have seen the name, code name Rome, and Rome is essentially our second generation product that is shown here, the picture at the top. It's actually a multi-die architecture. We pioneered that architecture in the first generation EPYC, but we enhanced it for second generation EPYC. And I'll touch upon the architecture very briefly here. One of the fundamental reasons why we've gone to a multi-die architecture is to actually to be able to scale to a very large number of cores and thereby give much higher performance on a per socket basis or even a per node basis. So this is our second generation EPYC, and as you can see from the picture at top, it's a 9-die multi-chip module. The smaller dies represent the core complexes. That's where our CPU, layer 2, layer 3 cache exists. And the centralized large die in the middle is what we call our I/O die. And this holds the memory controllers, PCIe lanes, all the South Bridge elements are all integrated. Now, with this technology, you do not need a separate South Bridge chip. Unlike, again, Intel, everything is integrated into the chip. And unlike Intel, which is a monolithic die, we support a multi-die configuration. Each die supports 8 physical CPU cores, and each core is multi-threaded. So net-net, what you get from this single socket solution is 64 high-performance x86 cores. And again, we're able to do that in this power footprint as well as space footprint because of multi-die technology. You know, in competitive technologies, you cannot go to large number of cores because you just hit radical scaling limits as well as essentially yield limits that prevent you to put all of this into a single die. So that's one of the key innovations we brought with second generation Rome, and we have now demonstrated the performance of that. I'll cover that in the subsequent slides. You know, in a quick kind of summary snapshot, they're roughly 2x performance versus the competition. It varies by workload. We'll cover some of those specifically. And again, that's a huge statement to say in the server industry, to be able to not just be better, not just be 10 or 20% better, but really be 2x of the competition. The other thing that we really focus on is bringing value to our customers beyond performance, and that's total cost of ownership. And we've done quite a bit of studies there, and you can actually save up to 50%, you know, in your TCO costs by switching over to EPYC. And again, there are details that are included, but you know, we have our own AMD TCO tool that's available on our website, and we've compared it against Intel Gold SKUs against our 64-core you know, processor. So, for example, 5 AMD servers can actually replace 20 dual socketed servers and actually be much better in terms of TCO savings. So the details are in the backup slides, but we are able to show up to 50%, and there are variances there. And the last area is around advanced security features. So I touched upon that earlier. We have a couple of unique technologies. Again, if you're interested, we could obviously do a deep dive around them. The first one is what we call secure memory encryption, or SME. Think of it as a hardware method to be able to encrypt all the data that sits in your DRAM, in your memory. And we have this essentially hardware crypto engine that sits on the path or on the path that writes to the memory and be able to encrypt the data in and decrypt the data as it leaves the memory back into the chip. So, we have that supported. All the AMD servers today support that as a BIOS option. So it's just a BIOS setting that you could turn on or off, and the performance impact is really minimal. Roughly 1 to 2% latency impact with secure memory encryption. And leveraging that technology, we have something else that's known as secure encrypted virtualization. And that allows you to essentially encrypt virtual machines that are run on the CPU. Again, we'd be happy to more than happy to cover those in more detail. Very recently, Google announced adopting AMD's secure encrypted virtualization technology in their confidential instance. So it's all available in the public domain for you to look at. But we have some really cool, exciting security features. And more and more customers are adopting them given the amount of outbreaks that we have in the security side. Kind of looking into the next level of detail about the product itself, the second generation EPYC or Rome processor. We support up to 64 cores, but we have different SKUs. I'll touch upon that as well. The advantage of having 64 cores is really a couple of things. One, you get very high VM density, virtual machine density, compute throughput. And another advantage is that you can actually collapse a number of two-socket offerings today. You can actually use a single-socket AMD server. So today we have wide adoption of both single-socket and dual-socket. In fact, our dual-socket is now actually really replacing quad sockets from the competition. So with that level of performance, we're able to actually really reduce the footprint in the data center, reduce energy consumption, and provide better TCO. One of the other differentiators is a number of PCIe lanes that we support. You can see here 128 lanes. We also support PCIe Gen 4. AMD is the first x86 processor in the industry to introduce PCIe Gen 4. It's been in production since last year. As I said, Rome was launched August of last year, and we have a very rich ecosystem of products that support PCIe Gen 4, including network interface cards, NVMe drives, as well as GPUs. Both AMD as well as NVIDIA GPUs are all tightly integrated with EPYC, and it really helps reduce I/O bottlenecks. So when you're looking to really push the performance envelope, and when it requires scaling to multiple nodes in the case of HPC, and I/O becomes a key bottleneck, and we are really doubling that bandwidth with PCIe Gen 4. And we work with very closely with Mellanox on their InfiniBand adapters, as well as with Broadcom on their Ethernet adapters, and we support up to 400 gig NICs from these partners. On the memory side, so we talk about there's the core compute element, right, which is the CPU. Then you've got the I/O that really sends traffic in and out, and then you've got the memory subsystem as well as the memory capacity. Those are other areas as well that AMD has made a huge leap in terms of feature capability. We support 8 memory channels, and more memory channels, the better it is for performance, and it allows you to pass data to memory, put it into memory, bring it back, We support 3200 memory speed. So again, that allows you to get very high performance for your applications. And the last is memory capacity. Memory capacity is really useful for database applications as well as memory analytics applications. And we support up to 4 terabyte per socket. And we don't charge a premium for supporting that. So today, you have partners that support 2 to 6 gigabyte of memory, and you can really scale up to 4 terabyte of memory per socket with that kind of memory solutions out there. Again, this is for customers that care about memory capacity. We support that without any added premium. Now, I won't go into all of these details of the SKU stack, but you can see here we have a range of offerings, right from 8 core at the very low end up to 64 core at the high end. So we cover the breadth of the market, and we have different SKUs with different clock frequency settings, etc. We have also some unique SKUs. I'll talk about it. The high frequency SKUs, the one that have a F as a second character, the 7F series. Those I'll talk about it a little bit more in detail, but these push the envelope in terms of CPU clock frequency for lower core counts. Again, when you have applications that are either bound by core scaling or have limitations in terms of core licensing, you would want to adopt the 7F SKUs, and we've specifically designed that, and we're very competitive when it comes to that, and addresses the kind of the heart of the data center market with these product SKUs. The other factor or other feature of our products is that we support the features of the product across the product stack. We don't have a confusing matrix of products and we don't force customers to be pushed up to higher core counts because you need a higher I/O capability. We support all of these features of I/O memory channels, as well as number of lanes of PCIe. All of them are supported across our product stack. So that's the other point. And the last point I'll mention is that you see a line that is called the single socket line here. And these products we have specifically called out single socket 8 core, 12, and 24, 32, as well as 64. The main difference, we have an equivalence queue, or we do have, in most cases we have an equivalence queue for a 2P version. In this case, the P version, the single socket version, what it means is that the socket-to-socket link does not work on these SKUs. So these are typically used in servers that are designed for single socket environments. You could use them in a dual socket environment, but in case you want to go and populate the second socket, you'll have to populate them both sockets with a non-P version. Hopefully that was clear. If you have any questions, I'd be happy to address them further. But we do have these single socket SKUs, and the reason we've introduced them is that we price them actually much more attractively. So again, it saves quite a bit of cost for our customers and overall benefits in TCO. Now I'm going to jump a little bit into the actual performance. So what we're doing here is we are looking at the second rate benchmark, and which is a very commonly used benchmark in the industry as a kind of, I would say, a starting point of comparison. And we are comparing on the left-hand side dual Intel Xeon Cascade Lake refresh processors. And on the right-hand side, we compare it with our second generation AMD EPYC dual socket processors. Now, as you can see, the performance in this case is the highest end with a 64-core processor is 701 to be precise. And as you look on the left-hand side, you can see the Intel Platinum SKU going up to 364. So again, this is a proof point of kind of why we excel in performance in the data center environment. Again, we have different SKUs that compare against different offerings. For the most part, the 32-core addresses the entire stack of and exceeds the stack of the Intel SKUs, but we have 48 and 64 SKU options as well. And again, our pricing philosophy on these products are not only we deliver higher performance, but we do it at a very, very competitive, price point as well. So again, that's one of the reasons why the AMD CPU is being widely adopted. HPC is obviously a very key segment for us, one of our key focus segments, and that's partly because HPC applications demand high performance, demand higher throughput, right? 400 gigabits InfiniBand is needed. High performance, high core counts are needed, and we're able to do that, with our EPYC second generation processor. Now I'm going to touch a little bit about the roadmap, kind of the imminent roadmap. As I said, our first generation product was codenamed Naples, introduced in 2017. We introduced second generation Rome in 2019, last year. And you can see here, we actually moved from 14 nanometer technology to 7 nanometer with Rome. The advantages with 7 nanometer, it's dramatic actually. Not only do you get better integration of transistors, but you also get quite a bit of power savings. Your TDP savings are quite significant with 7 nanometer. And we leverage actually for our CPU die, which I talked about earlier, 7 nanometer for the IO die, which really has a lot of SerDes and analog IP. You do not need a 7 nanometer node for that, so we use 14 nanometer technology for that one. Now going forward, we are well on our path on Milan. Milan is also based on 7 nanometer technology node. It's actually, I would say, an improvement in terms of CPU performance, and we are also keeping Milan fully pin compatible with Rome. So we have customers that are migrating from Rome to Milan without changing any of their hardware designs and just doing a BIOS update. So you get longevity for your infrastructure investment, and we're able to do that with Milan. Milan, is well underway, and you will see more announcements of Milan coming up in the near term. But we are executing to that on Milan as well as beyond Milan as well. So we have a strong roadmap beyond Milan as well. So I think what you can see here is that we've been executing very consistently. 2017 was the first product, 2019 was the second product, and we are on our way to production release for Milan as well. So things are, again, we're hitting our production timelines and execution timelines, and we have a very strong roadmap beyond Milan as well. Now I'm going to switch gears a little bit and talk a little bit about some of the workloads that this product was designed for. So right at the top, as I said, high performance computing, HPC, is a very key market for us. And we essentially, when we kind of push our product boundaries, based on what the HPC market needs, and they are the most demanding customer base in terms of performance. So we'll talk more about that. We have several wins in this space, including, as I talked about earlier, SDSC, but we also have other partners as well. We'll talk about that. The second major area, I would say, is around cloud, hyperscale, and virtualization. So think about it as public clouds. We'll talk about some of those partners there. We have a very wide adoption in the public cloud infrastructure, but also in enterprise virtualization and virtualization consolidation. We are growing that presence very strongly there, and that's a very key area of growth for us. The third area is around machine intelligence, and I would say there are a couple of points there. One is, AMD also has our own GPUs, AMD GPU, Radeon GPUs, and we address that market with AMD GPUs, but we also partner with NVIDIA. And NVIDIA, in fact, recently announced their DGX server to be based on AMD Rome CPU. So we work with NVIDIA on that, and we also work with them on getting their GPUs validated and certified with AMD. So we're closely partnered with our teams as well as our partners there to address the machine intelligence market. the next area of focus for us is big data analytics. And again, what we're doing there is we have a number of partners there that we work with, and they leverage the unique features on AMD, things like memory capacity, large memory capacity, as well as the I/O capabilities to deliver that. And last but not the least, software-defined infrastructure. To be very specific, we are very focused now with our second generation product on hyperconverged infrastructure, HCI, and we are working with industry leaders like you would say VMware, VxRail, as well as Nutanix, as well as others, SimpliVity and Azure Stack HCI. So we have a very broad range of hyperconverged offerings with our second generation EPYC. We are working with, again, key ecosystem partners across all of these industry verticals, and continue to deliver more ever-increasing range of solutions, fully certified, optimized for the AMD architecture. And so now, I want to give you some proof points. I talked about the spec and performance comparison, but we've also done a number of industry benchmarks, standard benchmarks that are there, and we've now at 170 plus world records. It keeps going up every time I do a presentation. We were around launch, we were somewhere around 100. We went to 150, and we are now at 170. Just keeps going as long as it's just it's just a matter of AMD being able to put resources, or our partners being able to put resources to claim some of these world records, really, because we have the leadership in terms of performance. And you can look at it where we've seen those these world records come across. 31 records in big data, cloud virtualization, 10. But HPC, you can see here, right? HPC, floating point energy efficiency, quite a number of world records, integer performance as well. And then on software-defined infrastructure and enterprise, we have quite a bit of integer, Java, and energy efficiency records as well. So again, this is again some proof points. You can go to amd.com/world records. It's at the bottom of the screen if you want to find out more details about these benchmarks and these world records. And some of the highlights, and what you can see here is a wide variety of applications. I'll start with the HPC applications. So you can see here ANSYS Fluent, Altair Radios, weather forecasting, GROMACS, and HPL. These are all very HPC oriented benchmarks. You can see here in some cases we are actually 2x better, or on a core basis we are much better. So we have a number of records there. And then some other traditional kind of areas around database, Microsoft SQL, transactions per minute, we are 10% better per core. When you take virtualization, the VMmark benchmark is a very commonly used benchmark, and you can see here much better performance on VMmark with the AMD EPYC. And then when you look at things like containers, Docker, etc., and then data analytics, Apache Spark. So wide range of benchmarks are there, and performance claims that we've been able to prove with the AMD EPYC. So I want to call out a couple of actually three new SKUs that we recently introduced, actually as recent as April, a couple of months back, or 3 months back. And the reason these are very exciting is that the clock frequency on these SKUs are extremely high. And again, when you get to lower core count, customers prefer higher clock because either their application cannot take advantage of 64 cores or 128 cores across 2 sockets, or they have a challenge in terms of software licensing limitations, particularly in the case of database and even hyperconverged HCI, which are largely based on core licensing. So So the 7F product series, here you can see here the 8-core, 16-core, and 24-core are really, the 3 new SKUs that are supporting very high clock rates, 3.5, in some cases 3.5 gigahertz, 3.7 gigahertz kind of clock frequencies. And you can see here also the applications that these are targeted. So commercial HPC apps, EDA is one of those use cases where you would want fewer cores and high clock rate. They don't, it's not a great application to run a lot of cores. Database, as I talked about, database performance really doesn't scale with a lot of cores, but need higher clock frequency. So, and then third area is hyperconverged infrastructure. So, this is pretty exciting for AMD because this is one of the areas where, I would say we were catching up, and now we've not only caught up but exceeded. So if you use the argument, my application doesn't use a large number of cores, it cannot scale, or I have software licensing costs, challenges, then certainly you can look at these products to fill the gap for those kind of applications. And in terms of customer adoption, I want to talk through some of these. Again, a key partner for us, SDSE, I talked about that. But we also have a couple of other wins that I'll cover in the next slide as well. Frontier and El Capitan, those are big wins for us, but also we have some of the other wins listed here on the HPC side. On the cloud side, we have very broad adoption of our product, and we have general purpose instances as well as workload specific HPC, analytics, database, VDI, et cetera as well. And then on the right-hand side, the chart that you see here at the bottom screen, what it is really the number of platforms based on AMD EPYC to address the enterprise market. So, you can see here, between our first generation, when we introduced our first generation EPYC, we had only about 22 platforms in the market. Not a lot, right? Now, as we grew in size, as our adoption got better, we introduced more platforms on first generation EPYC in 2018. But really, 2019, with the introduction of Rome, we've gone past 100, and now we're about 140, probably 150 now, but in that range. But you can see here that more and more partners are announcing platforms. A recent introduction is actually, as I said, NVIDIA DGX A100, AI server based on AMD Rome as well. So a lot of exciting platforms that have come out to address enterprise workloads, but also a lot of them feed into hyperscalers as well. So this is kind of gives you a view of the momentum in the market. Now, as I mentioned, I want to talk a little bit about a couple of big announcements that we made in the recent past. The first one is the Frontier announcement with Oak Ridge National Labs, and the target there is 1.5 exaflops, and this supercomputer is going to be expected to be more powerful than 100 of the fastest supercomputers combined. Production will be in 2021. And the other announcement is around El Capitan, and that's targeting 2 exaflops, and again, it'll be faster than 200 fast supercomputers, and production in 2023, so it's a little later. Both these products will be using AMD EPYC CPUs as well as Radeon Instinct GPUs. So inside AMD, we often call it as the A+A solution, AMD CPUs and GPUs. And for exascale, this seems to be really popular, just because of the tight integration that we bring in with our CPU and GPU, as well as some of the open source software elements that we bring in on the GPU side. The ROCm software stack is open source. It's not proprietary, and exascale, customers seems to prefer that. So combination of both hardware, tight integration benefits between CPU and GPUs, as well as the software on the GPU side, is really driving this big exascale wins for AMD. On the cloud computing side, I touched upon it. I'll just mention a few key names. As you can see, the who's who of the cloud computing world uses AMD. Microsoft Azure, Google Cloud, AWS, as well as Twitter, Dropbox, Oracle Cloud, etc., IBM Cloud, and others as well that are listed, Tencent, so Google has announced its largest general purpose VM after based on the AMD architecture. As I said, they've also recently introduced something known as confidential computing based on AMD security technology, the SEV technology, as I mentioned earlier, secure encrypted virtualization. So Google has just announced it very recently. So I would encourage you to look at that if you're interested. On Twitter, Twitter has actually they've actually disclosed that that with AMD EPYC, second generation EPYC, they're able to deliver 25% better TCO, and also we've also seen that our the database 64% better performance on Microsoft SQL Server as well. So on the Azure platform. So overall, very good stories. I would say cloud computing instances. AMD is obviously definitely now positioned as a performance leader, as a VM leader, right? Number of VMs, as well, and of course, when it comes to cost per VM, etc., we lead that as well. So, number of areas that our cloud partners are positioning AMD in the market. Okay, continuing on. Christine and team, is audio, everything is coming through clear? I just want to make sure.
You're good. You're perfect.
Excellent. So we're about 9:43, so I'll spend a few more minutes, make sure that we leave a little bit of time for Q&A at the end. So the other area which is a little bit of emerging, I would say, is telco and infrastructure. What we have now with our second generation EPYC Rome product, we are now addressing a new market opportunity, telco or telecom opportunity, which basically, if you're familiar with things like network function virtualization and other trends that are basically enabling telecom customers to actually, telecom providers to be able to move their infrastructure from purpose-built appliances over to general purpose x86 servers. That trend has been going on for the last few years. It's picking up steam, especially as you deliver more compute density and better performance. Your end application is just a piece of software running on a standard server instead of being limited to a tightly integrated appliance with long cycles of development, etc. So that's the trend that we're seeing both on networking and storage. On the storage side, I would say HCI hyperconverged is one of the areas which we are definitely focused on, but telecom is also another area, and where we've seen really the adoption of AMD EPYC in telecom is around really taking advantage of some of our product features. As I talked about, PCIe Gen 4 is a game changer, and we introduced that last year, right? And we're still the only available product, x86 product today that can support PCIe Gen 4. And I talked about 400 gigabits links. Again, this is very, very important for telecom, right? They deal in the network packet world, and they need high bandwidth capability. So our I/O enablement is really removes a lot of the bottlenecks that they have. On the NVMe side, as it relates to more storage-oriented applications, PCIe Gen 4 again delivers almost 2x I/O performance versus compatible PCIe Gen 3 NVMe drives. We also provide leading edge networking data plane performance. And data plane is really, if you look at a telecom operator, they have a control plane and a data plane. Data plane is where all the network traffic flows through, the user traffic flows through, and the different applications that run on it, whether it's packet core or whether it's virtualized RAN, those elements really need high throughput capability and high compute capability, and we're able to deliver leading performance there. I'll touch upon an example very specifically on this as well in the next slide. And as the networks transition to 5G, we see tremendous opportunity for AMD with our 64-core EPYC to be able to really, enable this transition to software-defined computing in the telecom network. So I think the combination of very high compute density combined with very leading I/O support, we are driving all of these. All of these partners are looking at and increasingly adopting AMD in their infrastructure. So specifically giving you an example on telecom infrastructure, we partnered with Nokia, who, as you know, is a leading telecom provider. And in this case, this is their cloud mobile gateway application that essentially does the packet core functionality, and it allows essentially, again, it's a software version of being able to run it on a standard server. And on the left-hand side, you see is the RAN or radio access network. Think of it as base station. Further left of that is the user itself. With us talking on cell phones, etc. And this goes to the packet core, where the entire packet core functionality is written in software and running on an AMD EPYC server. And to their testing and evaluation of AMD EPYC, they were using a competitor solution, a high-end competitor solution. AMD EPYC came in with PCIe Gen 4. They leveraged PCIe Gen 4 as well as the compute capability, and they were able to see 2x performance improvement with AMD EPYC. And we are very proud about this. And again, this is one of the leading telecom software providers, Nokia, and we are working with service providers on some of these adoption capabilities. Last couple of areas I want to touch upon is the ecosystem strength, and I touched upon it. We have a very large growing ecosystem. The advantage of AMD is that not only are we x86, we pioneered x86 64, so applications that run on our competitor run on AMD and vice versa. So and then when you take virtualization aspects, we work with key partners like VMware, as well as we support KVM. So all the virtualization elements are also standardized. So typically application porting to AMD is fairly quick. Optimization takes a little bit of effort, but taking advantage of the AMD architecture to get the best performance, is I would say a mild effort needed to get there. So on the top you see our OEM and ODM partners. You can see all the key OEM and ODM partners that we work with, HPE, as well as Dell EMC, Supermicro, Cisco, etc., Cray. And then you can see also a lot of our ODM partners as well at the bottom of the first section. And then you can see here we have a huge amount of hardware and software ecosystem partners that we work with. Some of the, as I said, I mentioned some of the hardware partners earlier for PCIe Gen 4. I mentioned VMware, Red Hat, obviously is a key partner for us. Microsoft, and you can see here, companies like Nutanix and several others. So it's a long list for me to walk through all of them, but you can see the big names are all there. We consistently are growing our ecosystem to support more partners and working deeper with our ecosystem to enable readiness, very early on in the production release cycle, as well as optimization. So, kind of leading to my conclusion section here, as we get to the last 10 minutes of the meeting here. So, as I said, we've now delivered on 2 generations of products very predictably as per schedule. The third generation product is on track as well. And second area, leadership performance. Again, hope by now you've seen some of the areas where we're particularly strong. We address the whole wide range of workloads. There's nothing niche about EPYC, AMD EPYC. We go after broad industry workloads. Anything that runs on the competition will do much better. And then the third area is around ecosystem support that I just talked about. Again, very it's a very robust ecosystem that we are investing resources as well as people. In the last couple of years, the team I'm part of has really dramatically grown in size in terms of engineers that we have in our team to be able to support all of these partners and work with them on optimizing and supporting them. So with that, I talked about this presentation, as a new era in data center. A new era, happens, or when there's a new leader, there's a new era. So I would say, with our leadership performance, AMD EPYC is certainly the performance leader, and we are very excited with the roadmap that we have, and the execution and the performance that we have. And the last area is around accelerated computing. I touched upon it, a couple of proof points around AMD CPU plus GPU wins that are driving the next generation of high performance supercomputers, and look forward to opportunity to engage with some of you that we've not talked to. And thank you, Ron, for the opportunity, and for all the attendees for taking the time to listen to the presentation. Really, it was a great experience. Thank you very much.
Thanks again.